When a magnesium ribbon is burnt in oxygen, it gets converted to magnesium oxide. This description of a chemical reaction in a sentence form is quite long. It can be written in a shorter form. The simplest way to do this is to write in the form of a word equation. The word equation for the above reaction would be magnesium plus oxygen gives magnesium oxide. The substances that undergo chemical change in the reaction, that is, magnesium and oxygen, are the reactants. The new substance, magnesium oxide, formed during the reaction is the product. A word equation shows changes of reactants to products through an arrow placed between them. The reactants are written on the left-hand side, that is, LHS, with a plus sign between them. Similarly, products are written on the right-hand side, that is, RHS, with a plus sign between them. The arrowhead points towards the products and shows the direction of the reaction. Now let us learn about writing a chemical equation. Chemical equations can be made more concise and useful if we use chemical formulae instead of words. A chemical equation represents a chemical reaction. If you recall the formulae of magnesium, oxygen, and magnesium oxide, the above previous equation can be written as Mg plus O2 gives MgO. Count and compare the number of atoms of each element on the LHS and RHS of the arrow. Is the number of atoms on each element the same on both the sides? If not, then the equation is unbalanced because the mass is not the same on both sides of the equation. Such a chemical equation is a skeletal chemical equation for a reaction. This equation is a skeletal chemical equation for the burning of magnesium in air. We all know that whenever a chemical change occurs, a new substance is formed. Such a change is referred to as a chemical reaction. A chemical reaction can be represented by writing the chemical formulae of the reactants and the products. Such representation of a chemical reaction is known as a chemical equation. In a chemical equation, the reactants are written on the left-hand side, that is LHS, and the products are written on the right-hand side, that is RHS. According to the law of conservation of mass, the mass can neither be created nor be destroyed in a chemical reaction. Thus, the total mass of the elements present in the products of a chemical reaction must be equal to the total mass of the elements present in the reactants. This means that the number of atoms in each element remains the same, both before and after the completion of a chemical reaction. Let us now learn to balance a chemical equation step by step. Let us try out with this example. Fe plus H2O gives Fe3O4 plus H2. Is this chemical equation balanced? Come on, let's find out. List the number of atoms of different elements present in the unbalanced equation on any of the sides. After listing and identifying the different atoms, start balancing the equation with the element having the maximum number of atoms in a compound. We find that Fe3O4 has the highest number of atoms with a maximum number of oxygen atoms in it. Two to balance, 1 into 4, 4. We must also remember that the formula of the compound or the elements involved in the reaction cannot be altered to equalize the number of atoms in the equation. This can be explained well in the given example. Here, to balance the oxygen atoms, we put the coefficient 4 before H2O as 4H2O. Balanced now? Yes, they are. But the iron and hydrogen atoms are still not balanced. We can clearly observe that there are 8 hydrogen atoms on the LHS but only 2 hydrogen atoms on the RHS. To balance the hydrogen atoms in this equation, we will have to make the number of atoms of hydrogen as 8 on the RHS as well. Therefore, the equation would now become Fe plus 4H2O gives Fe3O4 plus 4H2. Now the one element that is left unbalanced is iron, that is Fe. Atoms of iron in reactants, in products. Fe plus 4H2O gives Fe3O4 plus 4H2. Finally, to check the correctness of the balanced equation, let us count the atoms of each element on both sides of the equation. This method of balancing a chemical equation is called the hit and trial method, as this method employs making trials to balance the equation by using the smallest whole numbers as coefficient. Part 3. A chemical equation is made more informative by mentioning the state of the reactants and the products along with their chemical formulae. The gaseous, liquid, aqueous and solid states are abbreviated differently as G, L, AQ and S respectively. This can be understood better with the help of an example. In the given equation, Fe and Fe3O4 exist in solid state, whereas H2O and H2 are in gaseous form. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. are also indicated above or below the arrow in the reaction. In this example, 340 atmospheres indicates the pressure at which this reaction occurs. You must have often seen during whitewashing in your house, workers mixing lime, tuna with water. What happens? The mixture becomes hot and steam starts coming out. You must have seen burning coal changing into ash and smoke. You must have seen iron getting rusted. All these are the examples of chemical reactions because some new substances are formed in all of them. So, in a chemical reaction, the substances known as reactants are converted into new substances called products. But are all the chemical reactions same? Or there exist different categories of chemical reactions? In fact, chemical reactions are of different types, and in this module we will learn about them. Different types of chemical reactions are combination reaction, decomposition reaction, displacement reaction, double displacement reaction, combination reaction. Let us take a small amount of CaO, calcium oxide, in a beaker and slowly add in this reaction, CaO and H2O combine to form a single product, that is CaOH2. Such reactions in which two or more substances combine to form a single substance are called combination reaction. Example of combination reaction is when coal burns in air to form carbon dioxide. In this reaction, two elements, carbon and oxygen, are combining together to form a single compound, carbon dioxide. Reactions. Let us take about 2 grams of FeSO4, ferrous sulfate crystals, in a test tube. Hold it with a test tube holder and heat it over the flame of a burner. What do you observe? Green color of ferrous sulfate crystals changes to white, and then a brown solid is formed, which is ferric oxide, and a colorless gas having the smell of sulfur evolves out of the boiling tube. In fact, the ferrous sulfate crystals FeSO4, 7H2O lose water when heated to form anhydrous ferrous sulfate, which is white in color. It then decomposes to ferric oxide, Fe2O3, sulfur dioxide, SO2, and sulfur trioxide, SO3. Such reaction in which a single reactant breaks down to give simpler products are called decomposition reactions. Displacement reaction. Take a few iron nails and clean them by rubbing with sandpaper. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution. What do you observe? After some time, the iron nails become brownish in color and the blue color of copper sulfate solution fades. In fact, in this reaction, iron, which is more reactive than copper, has displaced or removed copper from copper sulfate solution. When zinc granules are placed in copper sulfate solution, zinc displaces copper from copper sulfate compound, and as a result, the copper is set free. The blue color of copper sulfate solution fades due to formation of colorless zinc sulfate. A reddish-brown deposit of copper metal is formed on the zinc granules. This displacement reaction takes place because zinc is more reactive than copper. Displacement reaction. Take colorless solution of sodium sulfate in a test tube and add colorless solution of barium chloride to it. What do you observe? Some white-colored insoluble substance is formed. Yes, when sodium sulfate and barium chloride reacts, soluble sodium chloride and insoluble barium sulfate is formed. In this reaction, barium sulfate is formed as a white insoluble solid called precipitate. Here, the exchange of ions takes place. Such reactions in which exchange of ions between the reactants takes place to form 2 new compounds are called double displacement reaction. Other example of double displacement reaction is the reaction of lead nitrate and potassium iodide, in which yellow precipitate of lead iodide and soluble potassium nitrate is formed. The insoluble barium sulfate and lead iodide are formed as precipitates. Any reaction in which an insoluble solid called precipitate is formed that separates from the solution is called a precipitation reaction. Oxidation and reduction. Let us take copper powder in a china dish and heat it. What do you observe? The surface of copper powder gets coated with black copper oxide. As oxygen is added to copper, it is called oxidation reaction. Such reactions where either oxygen is added or hydrogen is removed are called oxidation reactions. Now, if we pass hydrogen gas over the heated copper oxide, the black coating on the surface turns brown as oxygen is removed from copper oxide and copper is obtained again. Oxidation and reduction take place together. The oxidation and reduction reactions are also called redox reactions. The substance which gains oxygen during a reaction is said to be oxidized. And the substance which gives oxygen or removes hydrogen from oxidation is called an oxidizing agent. For example, in this reaction, copper 2 oxide is losing oxygen O2 and is being reduced to copper. hydrogen, H2, is gaining oxygen and is being oxidized. As here, one reactant gets oxidized while the other gets reduced during a reaction. Therefore, it is an example of oxidation-reduction reaction or redox reaction. You must have observed that iron particles shine when they are in a new state. However, they get coated with a reddish-brown powder when left for some time. Do you know what is this process of coating called? This process is commonly known as rusting of iron. Apart from iron, there are some other metals which get tarnished in this manner. Have you ever noticed the color of the coating formed on copper and silver? When a metal is attacked by substances such as moisture, acids, etc., it is said to be corroded, and this process is called as corrosion. The black coating on silver and the green coating on copper are other examples of corrosion. Corrosion causes damage to car bodies, bridges, iron railings, ships, and to other objects made of metals, especially those of iron. Students, corrosion of iron is a serious problem. Every year, an enormous amount of money is spent to replace damaged iron. Have you ever tasted or smelled the fat or oil-containing food materials which have been left for a long time unused? These fats and oils which have been left for a long time unused get oxidized and become rancid. As a result, their smell and taste also changes. This process is called rancidity. Usually substances which prevent oxidation, also called as antioxidants, are added to foods containing fats and oil. Keeping food in airtight containers also helps in slowing down the process of oxidation. Do you know that chips manufacturers usually flush bags of chips with gases such as nitrogen so as to prevent the chips from getting oxidized?